95% of VC method students don't know how to answer this question. In this case, we have a composite function, f of x is equal to the square root of x minus 3 multiplied by x minus 5, and we're asked to define the implied domain of this particular function. What we have to do is think about how a square root affects our domains or affects how we can actually evaluate numbers. And what we have to recall is that if we have the square root of any number, that number should be greater than or equal to 0. That's implying that if you have the square root of a negative number, it actually doesn't exist. And the square rooting of a negative number is actually the reason why an implied domain actually is occurring for any square root function. So in this case, what we're essentially saying is that whatever's underneath the square root, which is this quadratic equation in this case, this should be greater than or equal to 0. So we essentially just have to find where this parabolic function is above the x-axis or on the x-axis. And the easiest way of doing that is simply through a sketch. You can see it's already in factorized form. So this parabola is going to have x-intercepts at 3 and 5. So 3 would be there, 5 would be there. So this is what the parabolic function looks like. Now this would be 3, this would be 5. And if I just use a different color for this one, what I can try and imagine is that this is greater than or equal to 0 for this red region here, and then also this red region here. Essentially, it's just wherever the y value is positive or wherever the y value is 0. So if I wanted to define that red region as a domain, how I would do that is by saying x is an element of negative infinity to 3, and I'll union that with 5 to infinity. So this is a set of x values which makes this parabolic equation greater than or equal to 0, and therefore this is also the same set of values as our implied domain for f of x.